So the third chapter. So the MISRA rules. So learning objective is MISRA rule itself, what the MISRA rule is, and how to improve MISRA violation. So introduction. So these are the type of coding guidelines. So MISRA is located here. So coding guideline may classify these two parts. So one is coding law, one is coding style. So coding law purpose is avoidance of developers' mistakes or error. So for example, source C or source C++ or MISRA. And coding style, the purpose is high readability of source code and improvement of maintainability. So for example, Java coding convention and Google C++ style guide. So MISRA has also coding law, and some part of MISRA law has coding style. For example, how to put the comment on the source code, or how to indent the source code when you develop the software. So MISRA also has coding style, and almost all rule is coding rule. Why the need for MISRA rule? The one who applies MISRA rule is surprisingly aviation industry and national defense and railway industry also apply the MISRA rule on their product. Not only our OEM, such as Mercedes-Benz and Volkswagen or General Motors. So car manufacturer already apply the MISRA rule to obey the MISRA rule to make the product perfect, but also the aviation industry or the other industry usually apply the MISRA rule to make the software. So what is MISRA rules? MISRA C is a set of software development guidelines for the C programming language developed by Motor Industry Software Reliability Association. So in the association, we knew the Jaguar Land Rover or Ford Motor. This is the car manufacturer, and Delphi is the car component manufacturer, like LG. So these are the association. They made the MISRA rule, and the goal is code safety and security and portability and reliability. So the code developed by ISO C90 and C99. So this is the best practice to guideline for the safe and secure application. So history of MISRA C and MISRA C++. So MISRA C first edition is in 1998. So in 1997, they released the first edition, MISRA C 1998. So the total rule number is 127 rules, of which 93 are required and 34 are advisory. Required and advisory is a category, so a kind of priority to apply the software. So the priority is required is more prior to the advisory. And next one is MISRA C 2004. This is the second edition guideline for the use of C language in critical system in 2004. There are 142 laws, of which is 122 are required and 20 are advisory. I told you required prior to advisory. This is the rule category. And in 2013, they released the third edition, MISRA C 2012. So they support the ISO C99. Also, they support C90. So the total rule number is 143 laws and 16 directives. The directive is new terminology on from the MISRA C 2012. So I'm going to tell what the terminology is in the next section. So And MISRA C 2012, there are new category which is mandatory. So mandatory prior to required and advisory. So the prioritization priority is the first one is mandatory, and second one is required, and third one is advisory. And MISRA C++ 2008 is released in 2008, and total number is 228 rules, of which 198 are required and 18 are advisory, and 12 are document. I'm going to tell the terminology in next page. So these are the composition of MISRA C 2004. The MISRA rule guide document consists of the following. So in the 6 chapters, MISRA C 2004 guideline document total 106 pages, and chapter 6 has a rules. So 142 rules required and advisory are in here, and the rule number you can find if you violate rule 70.6. You can find it using this chapter. So these are the ISO source ID category undefined, such as undefined and unspecified, and implementation. These are the requirement text for this rule. So the rule guideline is look like this. The first one is rule number, and this is the category, as I told you. So there are 2 categories in MISRA 2004, required, advisory. And these are the requirement text. And these are the normative text, so explanation of underlying issues, and example and relevant rules. Some rules has example for compliant or non-compliant issues. And this is the composition of MISRA C 2012. So total page is 223 pages. So in chapter 7, you guys can find what the rule is. So this is the rule number and ISO standard source ID and amplification and rational. Amplification means more precise description on the guideline, and rational means the reason why the rule is necessary. An example, I told you, this is the non-compliant example. When you make the code like this is the violation of the rule 18.6. So this is the rule number, and this is the requirement text. And amplification, more precise description of the guideline. And rational is the reason why rule is necessary. You have to follow, you have to obey this rule because of this rational. And exception, some words has exception. When this case, you guys can ignore it, accept it. So situation in which rules does not apply. An example, I told you compliant or non-compliant example are described on this rule by rule. And there are 3 categories in MISRA C 2012. So this is the new category of which is mandatory. That mandatory rule has 10 rules, and this is the version of C language of guideline applied to. I told you C90 or C99. Some rules apply to C90, some rules apply to C99, but both are applied to some rules. And the analysis, so decidability and scope. Decidability describe the decidable or undecidable, and scope is single translation unit and system. So I'm going to tell what the meaning is to the next page. And also to MISRA C ++ 2008 has the same composition. This is the rule number, requirement text, why, reason why, or exception or example. It's the same with MISRA C 2012. So terminology in MISRA C, directive. Yeah. MISRA guideline has directive and rule. This is the different thing, because a directive is guideline for which it's not possible to provide the full description necessary to perform a check for compliance. In other words, if you want to check the compliance of this directive, you have to need some requirement specification. You don't decide the directive rule is correct or not. You have to need additionally requirement specification. But the rule is guideline for which a complete description of the requirement has been provided. So you don't have to need requirement specification or record some document to check the compliant the rule or not. And the decidability. So decidability, does this code comply with this rule? So the theoretical ability of static analyzer to answer the question yes or no. So a rule is decidable. This is the possible to answer a question with a yes or no. But in every case, but undecidable, every case they cannot say yes or no. Some kind of stuff, some case it could be yes, some case it could be no. So this kind of rule is undecidable. And the next one is scope of analysis. So the amount of the code that needs to be checked in order to detect the violation. So our rule is single translation unit rule. You can check it when you want to check the violation. You can find scope just in the file or some unit, single translation unit. But if the rule is a system scope, you have to find the violation reason through the system scope. And the next one is essential type. In MISRA C 2004, it called underlying type, but this is the same. This is the same terminology. So when the standard type of expression is unspecified, the standard type maps to essential type category. It's very hard to understand, so I'm going to tell it easily. If the integer I declared the integer I, int I, but the int usually has 4 bytes. 4 bytes is 32-bit. So, but int is signedness is positive. So positive, signedness is positive, and size is 32-bit. This is the essential type. Just I declare int I, but essential type is signed 32-bit integer. So the other case is I declared unsigned character. So unsigned character usually signedness is negative, and size is 1 byte. 1 byte means 8-bit. So when I declare unsigned character, its essential type is unsigned 8-bit integer. So you guys can take a look the essential type, what the type is, what the really essential type is. And the next one is composite expression. So expression which does not contain any constants and use composite operator, something like that. So example is a plus b minus c is a composite expression. The guideline just define this kind of sentence or expression is composite expression. So MISRA rule coverage by static analysis tool. Lure support coverage table is here. So we use coverage 80.7.1. So almost all lure they can support. So it means they can detect the MISRA rule 100%. So you can check the other lures support coverage in this link. And MISRA rule enforcement guide is OEMs. Every OEMs need obey the MISRA rule, but some OEM has their own rules to apply our product. So, for example, the GM wants to apply more than 100 rules to our product. MISRA C 2012 actually has 159 rules, but they just need to almost 100 rules. So these are some OEM's requirements. So when we insert the coverage to check the MISRA violation, we enable the rule requested by OEMs. So some kind of project rule enablement is different. The other one is 100 rules, or the other one is 80 rules. So many projects are different from the other project rule enablement. So this is the MISRA OEM requirement. So I told you GM MISRA rule set is 143. The total rule set is originally 159, but GM rule set has 143. So you guys can find it in this document. And Toyota or SsangYong BMW, they just, in this case, SsangYong just need MISRA C 2004, not 2012. They just need check MISRA C 2004, and they need to check 101 rules per 142 required rule. So this is the what the MISRA rule section is and I'm gonna tell the next session, MISRA rule violation informant guide, how to resolve the violation using the MISRA guidelines. So thank you for this listening to this module. So see you next module. Thank you. So this chapter is MISRA rule violation informant guide. So I'm gonna tell the guide to improve the MISRA violation. The most detected issue in VC MISRA compliance check. So I list up the rank which rule is detected a lot. So these are the rule list of MISRA C 2012, and these are the MISRA C++ 2008 violation. So MISRA C 2012 11.2. This rule is conversion shall not be performed between a pointer to an incomplement type and any other type. So, for example, in non-compliant example is, so in this sentence, SP is incomplement type because they just declare there's no definition. If the declaration is only here, the SP is incomplement type. So incomplement type variable SP is conversion to the other pointer type is non-compliant. So, but compliant example is this. So this example compliant with this rule, but so if the incomplement type variable SP, if you want to comply with this rule, you can assign the null pointer because exception 1. formation of the conversion to null pointer constant is okay to this rule. And next one, the value of an expression shall not be assigned to object with narrow essential type or a different essential type category. I told you the unsigned character or int I is a different essential type, as I told you. So here are some non-compliant example. So in this function, U16A assigned to U8A. So U mean is unsigned and number mean is size. So unsigned size 16-bit variable assigned to narrow bit variable. So this is the non-compliant issue because conversion to the narrow integer type. And next one is signed 8-bit A plus unsigned 8-bit A. So complicated arithmetic operation because the signedness is different. This is the signed variable, this is the unsigned variable. And in this function, foo1 using U16A parameter, but foo1 argument type is unsigned int A, but the parameter is unsigned 16A, so the size is different. So the narrower function parameter. So first this is 16-bit, but signedness is okay, but the size is 8-bit. So large parameter to narrow parameter. So this is the non-compliant issue. And finally, the return type. This function has a return type signed int 16-bit, but they try to return unsigned 16A. So the signedness is different. So this is the different signedness of the return type. So this is our non-compliant. So if you want to comply in this rule, you have to match the signedness and size, or just this is okay if you assign to bigger bit size variable. It's okay, but narrower is not okay. And these are the same signedness and size, and these parameter same size and signedness of foo1 function. And these are the match the signedness and size to this return type int 16 underbar t. So this is the compliant example. And the next one is identifier then define object or function with external linkage shall be unique. So for example, file1, file2 is here. So there are same identifier, so count is count, and the same function identifier foo and foo. But this is not unique identifier because can be externally linked. So you have to put the different identifier to make it unique. So in compliant example, you put just number 2 to make it unique. And last one is directive 4.6. Type definition that indicates size and signedness, because you have to understand what the size is and what the signedness is. So you have to use type definition to integer type or the other type. So it should be used in place of basic numerical types. So in this case, type definition is wrong because it's hard to figure out the size and signedness. You don't know what the size is in this type definition. So in the compliant issue is redefine the shape with size and signedness. So in this case, unsigned int type definition u int 32 underbar t. So you can notice, you can understand the signedness and size. And next is MISRA C++ 2008. So a variable which is not modified shall be const qualified. So const shall be used where the value is not changed. For example, in this function, this variable cannot change in this function. So you have to put the const qualified to this variable. So in the compliant example, you just put the const in front of the variable. So this is the compliant example. If you want to comply, Lure 711. And Lure, next one, 392 is it's similar to MISRA C 2012 Directive 4.6. You have to put the signness and size when you type definition. So you guys can notice this is assigned 16-bit size of variable. And next one is an implicit integral conversion shall not change the signness of the underlying type. Underlying type is equal to essential type. So implicit conversion with the change of the signness are not permitted. So this is the unsigned size 8-bit, but assigned to signed 8-bit. This is the different signness. So implicit conversion with the change of signness. And these are also unsigned 8-bit and signed 8-bit plus expression, and the result assigned to unsigned 8-bit. So these are the same with implicit conversion with the change of the signness. So if you want to comply this rule, just match the signness or size. So using static cast, before you plus expression, just type casting signed 8-bit to unsigned 8-bit and plus unsigned 8-bit value and assign to unsigned 8-bit. So our variable size and signness is the same. So explicit conversion using static cast if you want to comply with this rule. And the value returned by function having non-void return type that is not an overloaded operator shall always be used. So it means the return value of the non-void return type function shall be used. For example, in this function, function called using parameter power 2. So function has return type, and when terminate the function, return power 1. But they don't use anything. They just call and they just wrapped the return value. So in this case, you have to use return value using assign the return value to the other variable, or just typecasting to void type. So this is the comply with this rule. Okay, this is the improvement guide of what the rule is from the VC project, and I'm gonna tell you the next session, LG mandatory MISRA C 2012 rule guide. See you in next session. So in MISRA C 2012, they have the document has the new category called mandatory. So I'm gonna tell the mandatory rule. Total rule number is 10. So I'm gonna tell what the rule is. So first one is MISRA rule 9.1. The rule of an object with automatic storage duration shall be read before it has been set. It means do not read the value of an uninitialized local variable. So non-comply example, in this function, you integer 8-bit CHR variable and same type of CHE variable. But there's no local variable initialization. So in this for loop, they just plus expression and assign to plus expression to CHE variable. So you do not know what value is stored in the variable because they don't initialize the local variable. So result of wrong operation. So when you using the local variable, when you declare it, just initializing to 0. So if you do that, this will comply with this rule 9.1. And the next one is the operand of size of operator shall be contain any expression which has potential side effect. So the operand of size of operator should not contain expression with potential side effect. It means this is the size of operator and this is the size of operator operand. But the operand try to assign the value to UD variable. So this is the expression. So this is not compliant with because undefined behavior. And in this case, UD plus expression is operand of size of operator. So this is non-compliant. If you want to comply with this rule, do not perform operation with the size of operand. So this is the solution. If you really want to assign 1, 2, 3, 4 value to UD variable, just pop out and operate it and just put the UD of size of operator operand. So this is the same with the operation doesn't perform on the size of operator operand. And the next one is a function shall be declared implicitly. So it means function must not be declared implicitly because if you use this power function in here, you cannot notice the power function's declaration. So you don't know the power function's return type and the power function's parameter type. So this is wrong because the power function return type is double, but power function return value assigned to integer type. So this is the essential type is different. And also, this is the integer type and this is the double type. But the parameter type is first one is double, second one is int. So you guys want to match the essential type, you have to notice when you call the function. So explicitly declare function before using function like this. So you guys cannot make the mistake to make the software. So in this case, match the essential type. So return type is matched and the parameter type is matched with this declaration. So match the return type and argument type of the power function is complied with rule 17.3. And the next one is or exit pass from a function with non-void return type shall have an explicit return statement with an expression. It means this is the this function has return type integer 32-bit, but if the condition is false, there are no return values. So when the conditional statement is false, in the function is false, there is no expression to return, so which may cause undefined behavior. So if you want to comply with this rule, put the return expression to here. So return h, so you can comply with this rule. Int h variable is essential type is signed 32-bit size. So this is the same with return type of this absolute function. And the next one is the correlation of an array parameters shall not contain the static keyword between the array array. So in this case, total function has two arguments. The second argument can get the array from the parameter, but the v1 is just size is 10 array, but the total function parameter 2 wants to get 20 size array. This is not, it doesn't match to the side, so you just put away this static keyword when you want to get the array type of parameter. So delete static keyword is okay to this rule 70.6. And next one is object shall not be assigned or copied to overlapping object. For example, you assign character INA assigned here and short INA assigned here. So this is the overlapping of the memory address. So you just put away or just allocated different address, no overlap. So this is comply with rule 19.1. And the next one is a block of memory shall only be freed if it was allocated by means of standard library function. So, for example, you allocate some memory to P, and P address to assign to Q address, character pointer, but free P here, so free Q is free the same memory block again. And in this sentence, realloc function always free and then reallocation. So it's the free same memory block again. So if you want to comply with this rule, just free one time. If you alloc just one time, you have to free just one time. And the next one is there shall be no attempt to write to string which has been opened as read only. So in this case, file pointer fp is opened by read mode, but the developer tried to write some sentence. So in this case, C standard does not specify an operation when attempting to write to string open as read only. So if you open the file mode read, you have to you don't have to write. You must follow the mode. So when you open the file mode read, you have to use just read function like fread. So do not attempt to write to a file stream that has been opened as read only. And next one is kind of file pointer. So pointer to a file object shall not be dereferenced. So in this case, these are the file pointer and these are the file variable. But pf2 is file pointer, but dereference. Try to dereference pf2 and just assign to pf3. This is the violation of this rule because they were trying to dereference the file pointer. And these are also same. This is the dereference the operator. So if you change the value of the member variable file pointer, pf1, you will dereference pf1 and violate rule. So you just, if you want to allocate, if you want to assign the file pointer descriptor's address, just match the file pointer to assign to the same type and do not use the file pointer dereference. And the value of pointer to file shall not be used after associate stream has been closed. So in this case, you close the file pointer, but you try to write some sentence to use fprintf function. So this is the non-compliant example of Rule 22.6. C standard state that the value of file pointer after the stream is closed is intermediate. And if you want to comply this rule, just write it before finish or close the file pointer FP. These are the other MISRA violation improvement guide. You guys can go to this link and find it, what you need to improve the rule violation. So thank you for listening the improvement guide of the MISRA rule. So next session, we're going to deal with how to use the cover tool through the demo. Thank you.